This is lesson 56 of Saxon Algebra 1. It starts by talking about finite and infinite sets of numbers. A finite set, I'll write the word, a finite set is a set of numbers or members where there is what they call a finite number or a very specific number. And a set might be written like this: 6, 7, 8, 9, 10. In fact, I'm going to use a different, because they usually use those little brackets. So this is a finite set of numbers. It is representing this group of numbers of 6, 7, 8, 9, and 10. And nothing before or after. It's that specific set of numbers. It is finite. The opposite of finite is infinite. So if you have an infinite set of numbers, here's an example where you've 1, 2, 3, 4, 5. So far, it's looking like it could be a finite set, but all of a sudden I'm going to put in these 3 dots. Those 3 dots represent that this number keeps counting upward. And when there are just those 3 dots left, it is saying that that never stops. So when you write this infinite list, it's saying this list starts with 1, 2, 3, 4, 5, but continues in that same pattern, counting up by 1 infinitely. So you could never stop naming numbers in this list. It just goes on forever to bigger and bigger numbers. So this is called, the first one is called a finite set of numbers. The second set is called an infinite set of numbers. And again, these little dots are a really important difference between the two. Then we're going to talk about membership in a set. I have an example for you here. Okay, here's my example. I just wrote a big long list of numbers. There's a bunch of zeros, ones, and twos. In fact, there are 6 zeros, 4 ones, and 4 twos to be exact. But if I'm going to write this and designate these numbers as a set, and we're going to call them set B, we will write it set B equals this group of numbers, 0, 1, and 2. So it's a finite set of numbers because there are some zeros, ones, and twos, but we only need to note each number listed once. So if you have the set, for example, set D, if this is 1, 0, 1, 2, 3, and 4, this set consists of a 0 or any number of zeros. We don't even know how many zeros there could be, because again in set B we had 6 zeros. We're just saying there's at least 1 0 and at least 1 2, 1 1, 1 2, 1 3, and 1 4. We just don't know how many when you're just referencing a set. So here's an example of a problem they might have you work out to deal with these. They want you to look at this list of numbers. So you can look as I write them at our little list. And they want you to represent these numbers as members of the set K. So you're going to write K equals, and our nice little marker to show our set. And then we want to write them in numerical order. So we want to look at our list of numbers, find the smallest number, and represent it. And what helps me when I write a set like this is to go back to the original set and cross them out as I go. So when you look here, 0 is the smallest. And because I'm already writing my 0, I'm going to cross the others out, so I'm kind of keeping track of what I'm accounting for. The next number is a 1, so I can cross out my 1s. The next is a 2, cross out my 2. Now this is what I have left. And it looks like there's no 3s, so I won't put that, but there is a 4, so I'll write that and cross it out. There is a 5, in fact there are 2 of them, but I'll cross them both out. There's no 6, but there is a 7, so I'll cross those out. And doing that just helped me keep track of what I've accounted for. So I have everything. So the members of set K include 0, 1, 2, 4, 5, and 7. So that's how you work out those types of problems. Another example they give you is this list, and you can kind of look them over as I write them. And they want you to represent the following numbers as being a members of set L. Now, the order in which the numbers are listed is unimportant. So they're going to remind you that you don't necessarily have to go in order like we did before. That's my preference to do because it helps keep things in order more. But you could go in the order that they're listed in, and that might help you keep track better. So I'm going to start with this 7 and write a 7. And then I'm going to make sure to cross out any 7s I see in the row. I don't see any others. I'm going to write the 15 next. But there's another 15, so I'm going to be sure to cross that out so I don't accidentally write it twice. There's a 0, so I'll write that and cross out other zeros I see. There's a 1, but I don't see any others. Then there's an 8, a negative 13, oh, and not a negative, excuse me, and just a 42. So it is okay to put them in a different order, but sometimes things could get missed and you could accidentally write a number twice if you're not doing it in order from least to greatest. But either way, it is allowed to be written either way. Now, there's a couple symbols that are important here. Kind of looks like sort of a capital E, but not exactly. More curved. And the same symbol with a kind of cross through it. We use these symbols to designate that a particular symbol or number is a member of a given set or is not a member of a given set. So for example, if you see 0 and then this symbol here and then an L, what it's saying is 0 is a member of set L. So this symbol shows it's part of the membership of that set. If you have this written, 23, and then that same symbol, but it's crossed through, it's saying that 23 is not a member of set L. So it's not a difficult thing, but it's just sort of a new symbol you're going to see. So if you're given some sets, for example, so if you're given these 3 sets, set A, set B, and set C, some of them have different numbers and some have numbers in common. So they might ask you if this statement is true or false. 5 is a member of set A. So we need to look at set A and see, is 5 listed there as a member? And if it is true because it is a member of set A. The second one is 4 is a member of set B. Is this true or false? So or did I say B? I meant to say C. So we're going to look at set C and look carefully to see if 4 is a member. Because it is not listed there, this statement is false because 4 is not a member of set C. And then their last example, 5 is not a member symbol of set B. So we're going to look carefully at set B and see, is 5 a member? In fact, it is not because it's not listed there. So this statement is therefore true. 5 is not a member of set B. So do some of these practice problems, and I think they'll be pretty straightforward for you. But the next part they have, still within the same lesson, is called rearranging before graphing. And they kind of take a whole new concept to talk about. So they're going to ask you to graph an equation. So again, this doesn't have anything to do with the concepts they've just talked about. They're kind of switching gears and talking about graphing. And they're giving us an equation. And the first most important thing to do with an equation before graphing is to rearrange it so that we solve for y, because it puts it in a very standard form for writing a linear equation. So to solve for y, our goal is to get y all by itself. Because it's being added with this 3x over here, that's the first thing we want to get rid of. So we are going to subtract 3x on each side of that equation. When I subtract 3x, I'm just left with 2y equals 4 minus 3x. So far, so good. But here's another thing to keep in mind. Our goal that we want to get to the end is that we're solving for y, but then we want our x variable to be the next thing. So we might have a number before that x, and we might have something added to it after, but we really want to list it with the x first. So I am just going to stop and switch this side around so that the 3x is listed first, because it's just important to put it in that order. Then to get y all by itself, because we don't even want a number out in front of it like that too. So we are going to divide each side by 2. If I divide this whole side by 2, I'm left with y equals, and I'm going to divide this up. Instead of writing both of these terms over a single 2, I'm going to individually write them each over a 2, because I really want these two terms separated. So now that I'm at this point, I really, again, want a specific number out in front of my x and not necessarily with it. So I'm really going to look at this negative 3x over 2 as a negative 3/2 times x. So the x is still technically in the numerator with it, but it becomes important later when we're graphing to be able to just look at this individual number, even though it's being multiplied by x. And then here I can simplify the 4 over 2, because 2 can be divided evenly into 4. So it just becomes the number 2. So now that I have put it in this form, it makes it a lot easier to graph and to plug numbers in of giving x values and then solving for y values. So we're going to start with a 0, a 2, and a negative 2. You can pick almost any values for x. It's good to keep them close to 0. You don't want to pick giant numbers. And sometimes you want to look at your equation and pick numbers that are easily solvable. The reason they use 2's or multiples of 2's is because there happens to be a 2 in the denominator, and that's going to make it easier to solve. So I'm going to take each of these numbers and plug them into our equation. So I'll rewrite y equals 3 over 2, and I'm going to plug in my first number for x, which is 0. When I do that, the 0 multiplies by that fraction and basically gets rid of it and turns it into 0. Added to 2, it's just left with a 2. So 0 is always a good number to use for x. Then if I replace my x with a positive 2, I'll write it over here this time. If I put a positive 2 in there, now when I solve it, it makes it easier because this 2 in the denominator can cross out because of the 2 I just multiplied by it. So it just becomes negative 3 plus 2. and negative 3 plus a 2 ends up being a negative 1. So now I've found 2 points already. There's one more to go. We're going to find this negative 2. So I'm going to kind of box those so they don't look like they're part of the same thing I'm writing. But I'm going to keep that there so we can see it. So I'm multiplying it by a negative 2. And again, because I've used a multiple of 2, this just crosses out the denominator, but I'm still left with that negative. So a negative 1 times a negative 3 becomes a positive 3. And we're still adding it to that 2. So in this case, y becomes a 5. So I was able to generate the 3 points. It really helped that I was able to solve this original equation, or actually this was the original equation. Because I could solve that for y, it made plugging in these x values easier because we're already set up to solve for y. So if we're going to actually put these on a graph, these numbers here, I am going to erase so I can fit a graph on this same page so that you can see it right along with these numbers. So if this is my graph, I'm going to graph this first set of numbers, which can be written as 0, 2, because I always want the x value written first and then the y value. So if I make little notches that each represent 1, and it's not exact, but as close as we can. So my x-axis, I'm going to move 0 to the right or left. But for my y-axis, I'm going to move up positive 2. So I'm going to stay at 0, moving left or right, but I'm going to move up 2. So this is the point 0, 2. Then the next point I'm going to graph is the point 2, negative 1. So because my x value is 2, I'm going to move to the right 2, and then I'm going to move negative 1 on the y-axis to move down right there. And then my last set is negative 2, 5. So for negative 2, 5, I'm going to move 2 spots to the left in the negative direction on my x-axis, and then 5 up. I wasn't even prepared for that. I have it marked to 3, but I need to go a little further, mark up to 5. So it'll be approximately right there. And then as you can see, if you look at my 2 other points, I'm going to try and draw a straight line. As straight as I can with this pen. So this is my line created by those 3 points so that I could graph them. So again, your first goal when you're given your initial formula is to solve for y. Then you create a box, choose solutions for x. It can be any number you want. Some numbers are easier to work with than others, but they could be any number. And then you solve each of those to find the y value and then graph those values. I think we'll do one quick example. If you're given y minus x equals 0, this is their other example in the book, and you're told to graph it. This is a little different situation because there are not a lot of numbers involved. But we're going to use the same concept where we want to solve for y. This is pretty simple because to get y by itself, we need to add an x to both sides of the equation. So here, we're just left with y on this side and a positive x on the other. So that's pretty straightforward. So if I create my box of x and y values, you only need 2 points to make a line, but 3 points help you sort of confirm your line. So they chose numbers at random. It's always good to start with 0. They decided to do 3 and negative 3 also, but you could use other numbers. So if I plug a 0 in for x, what you realize is since y just equals x, if I plug a 0 in for x, it just becomes y equals 0. If I plug a 3 in for x, it becomes y equals 3. And if I plug a negative 3 in for x, it becomes y equals negative 3. This is an interesting example problem they chose because it's pretty simple to work out from that level. And then if I'm graphing it, I'm going to make sure I go to at least 3 little marks. So I am then graphing these 3 points. The first point will be 0, 0. The second point will be 3, 3. And the third point will be negative 3, negative 3. So I'll do them in a different color here so you can see. So here's the point 0, 0, the point 3, 3 up here, and the point negative 3, negative 3 is down here. So you can see you can draw, I didn't quite get through that. That's just for my own not steadiness, but it should go through all 3 of those points. So, same principles. You start with the given equation, solve it for y, choose 3 points or 3 values for x, solve each of them for y, and then plot your points and draw your line.